In this class, let us discuss about volume by triple integrals. I am Dr. P. Jyothi. So let us continue with the problem. Find the volume of the tetrahedron bounded by the coordinate planes and x by a plus y by b plus z by c is equal to 1. Find the volume of the tetrahedron bounded by the coordinate planes and x by a plus y by b plus z by c is equal to 1. Okay. So here given the region of integration is bounded by the planes and the plane x by a plus y by b plus z by c is equal to 1. Therefore, z varies from 0 to z is equal to c into 1 minus y by b minus x by a. So from this one here z by c equal to 1 by c, z by c is equal to 1 minus x by a minus y by b. So z is equal to c into 1 minus y by b minus x by a. Y varies from 0 to y is equal to b into 1 minus x by a. So in this equation, if you substitute z is equal to 0, then x by a plus y by b is equal to 1. Therefore, y by b is equal to 1 minus x by a. Therefore, y is equal to b into 1 minus x by a. Again, x varies from x is equal to 0 to x is equal to a. Okay, in this substitute, if y also 0, we'll get x by a is equal to 1. From that, x is equal to a. So, the limits for z are z is equal to 0 to z is equal to c into 1 minus y by b minus x by a, and the limits of y are y is from 0 to y is equal to b into 1 minus x by a, and the limits of x are x is from 0 to a. Therefore, the required volume is equal to triple integral over v dx dy dz. Okay. So, in this take substitution, x by a is equal to some capital X, y by b is equal to some capital Y, z by c is equal to some capital Z. Therefore, x is equal to a into capital X, y is equal to b into capital Y, z is equal to c into capital Z. Okay. Therefore, the limits x is from 0 to x is equal to a. The limits x is equal to 0 to x is equal to a will change into, okay, whenever x is 0, capital X is also 0. X is equal to 0 to capital X is equal to small x by a by a is equal to 1. Okay. Therefore, the limits of capital X are from 0 to 1. Similarly, the limits of y is equal to 0 to y is equal to b into 1 minus x by a. This implies whenever y is equal to 0, capital Y is equal to y by b, which is 0 by b, which is again 0, and 2, whenever y is equal to b into 1 minus x by a, our capital Y is equal to 1 by b into 1 minus x by a is our capital X. So b gets a cancel. So capital Y is equal to 1 minus capital X. Coming to the limits of z. Z is equal to 0 to z is equal to c into 1 minus x by a minus y by b. That implies whenever z is equal to 0, capital Z is equal to small z by c, which is equal to 0 by c, which is again 0. Coming to the upper limit. So whenever small z is equal to c into 1 minus x by a minus y by b, we have capital Z is equal to 1 by c into 1 minus x by a minus y by b. So here c gets a cancel. 1 minus small x by a is our capital X, small y by b is our capital Y. Therefore, the limits of capital Z is equal to z is equal to 0 to z is equal to 1 minus capital X minus capital Y. Therefore, our volume is equal to triple integral over V dx dy dz, which is equal to capital X is from 0 to 1, capital Y is from 0 to 1 minus capital X, and capital Z is from 0 to 1 minus capital X minus capital Y, small a, b, c into d capital X, d capital Y, d capital Z. Because here x is equal to, here x by a is equal to capital X. X by a is equal to capital X. That implies dx by a is equal to d capital X. That implies dx is equal to a into dx. Similarly, y by b is equal to capital Y. This implies dy is equal to b into d capital Y. Similarly, z by c is equal to capital Z. So, dz is equal to c into d capital Z. Therefore, dx is equal to a into dx, dy is equal to b into d capital Y, dz is equal to c into d capital Z. Since a, b, c are constants, they can be taken out of the integral. Okay, this is a, b, c into x is from 0 to 1, capital Y is from 0 to 1 minus capital X, Z is from 0 to 1 minus capital X minus capital Y, dx, dy, dz. Now we have to integrate this one. Therefore, the required volume is equal to a, b, c into x is from 0 to 1, y is from 0 to 1 minus capital X. Since the limits of z are in terms of x and y, so we integrate first with respect to z. So z is from 0 to 1 minus x minus y, dz into dy into dx. So this is equal to a, b, c into x is from 0 to 1, y is from 0 to 1 minus x. Integral of dz is z between the limits 0 to 1 minus x minus y into dy into dx. This is equal to a, b, c into x from 0 to 1, y from 0 to 1 minus x Substituting the upper limit 1 minus x minus y minus lower limit 0 into dy into dx. This is equal to ABC into integral x equal to 0 to 1 and integral y is from 0 to 1 minus x. Okay, 1 minus x minus y into dy into dx. Next, we are going to integrate this with respect to y. This is equal to ABC into x is from 0 to 1, y is from 0 to 1 minus x, coming to the 1 minus x minus y. 1 minus x minus y dy into dx. This is equal to ABC into x is from 0 to 1. Integral of 1 is y. While integrating with respect to y, x is constant. So this is integral of x is x into y minus integral of y is y square by 2 between the limits 0 to 1 minus x into dx. This is equal to ABC into x is from 0 to 1, substituting the upper limit, that is 1 minus x in place of y. 1 minus x into 1 minus x minus 1 minus x whole square by 2 into dx, because the lower limit is 0. Y is present in all the terms, the lower limit becomes 0. So this is equal to ABC into integral x is from 0 to 1, 1 minus x into 1 minus x minus into minus plus x into x, x square minus of 1 minus x whole square is 1 plus x square minus 2x by 2 into dx. This is equal to ABC into x is from 0 to 1. 1 minus x is 1 minus 2x. Next one, 1 minus 2x plus x square minus of 1 plus x square minus 2x by 2 into dx. I have to write the capital letters. 1 minus 2x 1 minus 2x plus 1 minus 2x plus x square minus of 1 minus 2x plus x square by 2 into dx. This is equal to ABC into, from these two terms we can take common 1 minus 2x minus x square. So this is 1 minus 2x plus x square into 1 minus 1 by 2 into dx. Because 1 minus 2x plus x square is present in both the terms, we can take it as common. So this is equal to ABC. 1 minus 1 by 2 is 1 by 2. Because 1 by 2 is a constant, we can write this outside the integral. This is ABC by 2 into integral x is from 0 to 1. 1 minus 2x plus x square into dx. This is ABC by 2 into integral of 1 is x minus integral of 2 into integral of x is x square by 2. Integral of x square is x cube by 3 between the limits 0 to 1. Integral of 1 is x minus 2 is constant. Integral of x is x square by 2 plus x square integration is x cube by 3 between the limits 0 to 1. This is ABC by 2 into substituting the upper limit 1 minus here 2 gets cancelled. 1 minus 1 square plus 1 cube by 3 is the upper limit. I mean, your lower limit is 0 because x is present in all the terms and x value is 0 minus 0. So this is equal to a, B, C by 2 into here plus 1 minus 1 square. Minus 1 square is minus 1 only. Okay. So minus 1 minus 1 is 0. 1 cube is 1. 1 by 3. So the value is A, B, C by 2 into 1 by 3, which is equal to A, B, C by 6. Therefore, volume of the tetrahedron, therefore, volume of the tetrahedron bounded by the coordinate planes, bounded by the coordinate planes under the plane x by a plus y by b plus z by c is equal to 1 is a, b, c by 6. Okay. So this is how we have derived the volume of the tetrahedron bounded by the planes, coordinate planes and the given plane. That's all. Thank you.